Okay, so in this video we're going to use the pH and the Ka to find the initial concentration of an acid. So coupled with the other two videos, this shows you how to use two of three unknowns to solve for the third in all three of those scenarios. So once again, we're going to set up the race chart for our reaction. So HCN aqueous is dissociating into H plus and Cn minus, cyanide ion. And if we look at the Rice chart, our initial concentration, we don't know what it is. We're trying to solve for that. I'm just going to put a y there. For H plus, 0 and 0 here. For the change, therefore, minus x plus x plus x. And we're going to end up with, at equilibrium, x, and y minus x. Alright, so given that we have set up this chart, I'm going to just move this a little bit out of the way. Now we're going to get to figuring out how to solve this. The first thing we can do is we can take the pH, which we know we're given as 5.15, and we're going to take the inverse log of this and find that the concentration of H plus is equal to 7.1 times 10 to the negative 6th molar. Alright, so given that we have 7.1 times 10 to the negative 6 molar as our concentration of H plus, we now know that this right here is going to be equal to X. Okay, so I'm going to go in and I'm going to set up the Ka, therefore, using that for the X. So Ka is going to be concentration of H plus, concentration of Cn minus, all over the concentration of HCN. And that, therefore, is going to be equal to x squared over y minus x, or 7.1 times 10 to the negative 6th squared over y minus 7.1 times 10 to the negative 6th. And if we look up the Ka on a table, or from earlier problems, we know that it is 4.9 times 10 to the negative 10th. We can go ahead and solve this for y. The simplest way to do that, as you know, is to just flip these two. So basically, divide both sides by 4.9 times 10 to the negative 10th, and then multiply both sides by y minus 7.1, and then all you have to do is 7.1 times 10 to the negative 6 squared divided by 4.9 times 10 to the negative 10th plus 7.1 times 10 to the negative 6. So straight algebra here, and you end up with y equal to 0.102 molar, and with the correct number of significant digits, that is y equals 0.10 molar. And there you go. We've now used the pH and the Ka to find the initial concentration. So just keep in mind that when you look at these different videos, really we're looking at here is that our initial concentration, Y, our concentration X, which is concentration of H plus, or the Cn minus in this case, whatever the conjugate base is, at equilibrium, X, and the Ka, those are really three variables, and you can have different ways of getting to and from them, but you have to be given two of the three, or a way to find two of the three, in order to solve these problems.